Hello, today we are going to start a new topic called as Fourier Transform of derivatives. What are those? So we'll just have some Fourier values and that we have to substitute and we should get some values. So that we have to do it today. So before that, what we have done in the last lecture is we have done the convolution theorem. So in that we have proved that the L of integral 0 to t f1 of t and f2 of t minus x dx is equals to f1 of s into f2 of s. So we have done a full proof for this. Okay, so as we are going to start a new topic, that is the Fourier transform of derivatives. So let's start that. So Fourier transform of derivatives. Now as we know, the f of fn of x is equals to minus is of n into f of s. Okay, so one by one we will solve the derivatives. That is, first is f of d square u upon dx square is equals to I into s square, and f of u of x, which comes out to be minus s square, which is equals to minus s square into u bar. So where what is u? U is the Fourier transform of u with respect to x. Second, we have to prove that f of c, where f dash of x is equals to minus 2 by pi f of 0 plus s f of s into s. So let me solve the LHS part. Okay, and we should get the RHS part. So LHS, so we will solve that LHS. So square root of 2 upon pi integral 0 to infinity f dash of x cos sx dx is equals to, so this term is equals to square root of 2 upon pi integral 0 to infinity cos sx d means that is derivative, one derivative, f of x, okay, which is equals to square root of 2 upon pi, which will give me f of x cos s of x, which is in the limit 0 to infinity, plus s 0 to infinity f of x into sine s of x into dx. Okay, now s f of x, so this is s f of x minus square root of 2 by pi f of 0, assuming f of x tends to 0 as my x tends to 0. So hence we have proved with what we have to explain here. Okay, so next is equation 3, third derivative, Fourier transform of its derivative, that is f of s f dash of x, where square root of 2 pi, which will be integral 0 to infinity sine s of x d of f of x, which is equals to square root of 2 upon pi which will give me f of x sine s of x 0 to infinity minus s 0 to infinity f of x cos s of x into d of x. As a result, what we are getting it is here is minus s f of c into s. Hence, we have got this value. Last, not the least, one more step is there. No, this is not the last. This is the second last. So, f of c. This was page number what? Page number 9. This will be 10. So f of c bracket f double dash of x is equals to square root of 2 by pi integral 0 to infinity cos sx d f dash of x. Okay, so how we will proceed with this proof? Let's see. So what we are having is the values square root of 2 by pi, then bracket f dash of x into cos sx integral in the limit 0 to, that is in limit 0 to infinity, plus s integral 0 to infinity f dash of x sine sx dx. So which will give me minus square root of 2 by pi f dash of 0 plus s f of x. So f dash of x. So which is equals to minus of s square fc of s minus square root of 2 by pi f dash of 0. So assuming what we have assumed, f of x and f dash of x tends to 0 as our x tends to infinity. Okay, I hope this part is also clear. Next, last one, where f of s is f double dash of x is equals to square root of 2 by pi integral 0 to infinity sine s of x d f dash of x, which is equals to square root of 2 by pi f dash of x sine sx sx. This is 0 to infinity minus s integral 0 to infinity f dash of x cos sx dx. So what we are getting it here is minus s f of x f of c f dash of x, which is equals to minus s to s f of s to s minus 2 by pi f of 0. So which is giving me minus s square f of s plus square root of 2 by pi s f of 0, assuming we have assumed the values of f of x, f dash of x, and which are 0. Why? Because the value of x going to infinity. So with this, we have completed the topic called as the Fourier transform of derivatives. Okay. Now we are going to start a new topic called as relationship between the between Fourier and Laplace transform. So we have to consider f of t is equals to e raised to minus st gt for value of t greater than 0, which is my equation number 1, and this is 0 for t less than 0. So then the Fourier transform of f of t is given by f of ft, which is equals to 1 upon square root of 2 pi integral minus infinity to infinity e raised to ist f of t dt, which is equals to 1 upon square root of 2 pi integral 0 to infinity e raised to is minus x into t into g into t into dt. Okay, so page number 11. So which is giving me 1 upon square root of 2 pi integral 0 to infinity e raised to minus of p t. I have substituted the value of minus that is minus s minus is minus x as p minus p. So gt dt, where what is p? P is the x minus is, that is opposite, so that's the reason it becomes minus p, which is equals to 1 upon square root of 2 pi L of g of t. Hence we have proved that therefore the Fourier transform of f of t is equals to 1 upon square root of 2 pi into Laplace transform of g of t defined by 1. So hence proof. What is that 1? That is in equation 1, which we have written it here in the page, this page. Okay, so I hope you have understood what we have done in today's lecture. We have found out the Fourier transform of derivatives. So first derivative was f of d square u upon that is dou square upon delta square u upon delta x square, which is equals to is the whole square f of ux. Second was fc of f dash of x is equals to square root of minus of 2 upon pi f of 0 plus s f of s into s. Third is f of s in the f dash of x is equals to square root of 2 upon pi integral 0 to infinity sine sx d f of x. Then f of c is equals to f double dash x is equals to square root of 2 by pi 0 to infinity cos sx, that is d into f dash of x. Then last not the least, that is the fifth one, f of x into f double dash of x is equals to square root of 2 by pi 0 to infinity sine sx d f dash of x. Then the relationship between the Fourier transform and a Laplace transform is this we have to prove. So we have proved that Fourier transform is equals to 1 upon square root of 2 pi into Laplace transform on gt. Okay, So I hope up till here it is clear what we have done in our today's lecture. So as a result, thanks for watching.